Hello everyone! Today we are going to look at how to implement a money system in Unity using gold, silver, and copper coins. We'll assume that one gold coin equals 100 silver coins and one silver coin equals 100 copper coins. Let's start by creating a new script, which we'll call money. We can then edit this script. First, we need to decide whether we want to create a class or a struct. Given that we are going to be working with simple, lightweight data, just a few numerical values, I'm going to create a value type, so a struct. We can now think about how to store the amount of money. We could use 3 hints to store the amount of gold coins, silver coins, and copper coins. But I don't really like this approach. It's going to make the calculations complex, and we are using int values for silver and copper when their values can't exceed 100. You could use bytes for silver and copper, but that doesn't simplify the calculations. Let's take a look at this quantity of money. 1234 gold coins, 56 silver coins, and 78 copper coins. We could store this value in a single number, which would represent the total quantity of copper coins. Having a single number will help simplify the calculations. We'll therefore declare a single int, which we'll call amount. So be careful about the maximum value an int can take. As we use the last digits to store copper and silver coins, we only have room for just over 200,000 gold coins. If this limit is too low for you, you can replace the int type with the long type, in which case the maximum value is much higher. Yeah, I think there is enough here. For the rest of the video, I'll stick with the int type. We can now add constructor to our structure. The first constructor will take just one parameter, the total amount of copper coins. The second constructor will take 3 parameters, the amount of gold coins, silver coins, and copper coins. In this case, we need to convert those values into the equivalent in copper coins and add them together. One gold coin equals 10,000 copper coins, and one silver coin equals 100 copper coins. We have stored the amount of money in a single variable in the form of its equivalent in copper coins. But we probably want to display the values in gold, silver, and copper coins to the player. So we need to implement a public method that allows us to retrieve these values. So we need to return 3 different values for the 3 types of coin, and to do that, we are going to use a tuple of 3 ints. We'll call this method getCoins. To retrieve the quantity of gold coins, we need to get the result of the whole division by 10,000, since 1 gold coin equals 10,000 copper coins. To obtain the quantity of silver coins, we first have to discard the gold coins, so we only keep the remainder of the division by 10,000. Then we divide by 100, since 1 silver coin equals 100 copper coins. And finally, to find the quantity of copper coins, we can take the remainder of the division by 100. All that remains is to return the tuple made up of gold, silver, and copper coins. Now let's test it to see if it works. We are going to create a new monobehavior script called example. In the starts method, we'll create a variable of type money, for example item price, and we'll initialize it with a value such as 12 gold coins, 34 silver coins, and 56 copper coins. Then we'll retrieve these values and store them in a variable called coins. We are now going to display the amount of coins in the console with a debug.log. To access the different values in our tuple, we add a dot at the end of the variable name, and we can now access item 1, item 2, and item 3, which correspond to the gold, silver, and copper coins. To test, we'll create a new game object and add our script to it, then click play. You can see in the console that the correct values have been retrieved. So the names item 1, item 2, and item 3 are not very explicit. To correct this, we have several options. The first is to name the elements in the method's return type. This way, we now have these names instead of item 1, item 2, and item 3. The other way would be to use tuple deconstruction, either by using var and then the names in parentheses, as here var parentheses, gold, silver, and copper, or by specifying the type of each variable, so int gold, int silver, and int copper. Now let's try to create a field that we want to display in the inspector. So we'll create a private field of type money, which we'll call item price, and we'll add the serialist field attribute to it to display it in the inspector. If we go back to Unity, we see that our field is not displayed in the inspector. We need to tell Unity that our struct can be serialized. To do this, we'll add the serializable attribute to our struct. This attribute is in the system namespace, so we can write system.serializable or add a using system at the top of our script. We are also going to add the serialist field attribute to the amount field. Now that we've fixed that, we can change the value directly from the inspector. This isn't very practical. You have to click on the little arrow to display the field and enter the total quantity of copper coins. You can change the display using a property drawer, which I'll show you in another video. In our example script, let's add another field of type money, and this time we'll call it a variable money. I now like to display a message in the console at start to indicate whether we have enough money to buy the item whose price is in item price. So we could expose the value of amount and access it to compare values. But it will be simpler to be able to compare money types directly. And to do that, we can use operator overloads. Let's start with the less than operator. Start by writing public static then bool, since the result of the comparison will be a boolean, then the operator keyword followed by the operator you want to override, in this case less than. Then between parentheses the two elements to be compared. Here we want to be able to compare two money types with each other. The first being the one to the left of the less than sign, the second being the one to the right of the less than sign. The result of this comparison will be the result of the comparison of the amount variable. Comparison operators must be implemented in pairs, so since we've just overloaded the less than operator, we need to implement the overload for the greater than operator. We can also override the operators less than or equal to and greater than or equal to. Now that that's done, we can go back to the example script and make our comparison. So if item price is less than or equal to a variable money, we display a message in the console to say that we can buy this item. And if not, we display a message in the console to say that we don't have enough money. We can also implement overloads for the equality and inequality operators. When we implement these overloads, we must also implement the overrides for the equals and getHashCode methods. For the equals method, we will consider that the other object is equal if it is also of type money and if it contains the same amount of money. So we'll start by checking its type. And using pattern matching, if the type matches, we'll store it in a variable that we'll call money. We'll then check whether our amount variable is equal to the amount variable in the other objects. And for the getHashCode method, we'll simply return the hashcode of our amount variable. We can also overload the arithmetic operators. In this way, we can use the money type directly in our calculations. For example, we can implement an overload for the addition operator. This time, the return type of the overload will be the money type, and we return a new money type value which contains the sum of the amounts of the two money objects. The same thing can be done with the subtraction operator. We can now test this in our example script. If you can buy the item if you have enough money, then we deduct the price of the item from a variable money and display the money remaining in the console. For the test, we'll set the price of the item to 1 gold and 50 silver coins and the available money to 5 gold coins. If we click on play, we can see in the console that we now have 3 gold coins and 50 silver coins left. So our subtraction has worked. We can also overload the multiplication operators if you want to multiply our money value by a float. This can be used if you want to calculate discount percentage for merchants based on reputation, commission charges, or repair costs, for example. So this time we need to convert the result to an integer, because the result of multiplying by a float is a float, and we are interested in an integer. So we can either do a cast to keep only the integer part, or do a round to int to have the result rounded and converted to an integer. Note that this will only work if the money type is to the left of the operator and the float to the right of the operator. Since this is the order in which we declared them, we declared money first and float second. So money must be to the left of the operator and float to the right of the operator. So if you want to be able to invert the two terms, in other words have a float on the left of the operator and a money on the right of the operator, we need to implement the overload a second time, but in the other order, with the float on the left hand side and the money type on the right hand side. And that's it for this video. I hope you found it useful. Don't forget to subscribe and like the video. If you have any questions, don't hesitate to ask them in the comments. Thanks for watching and see you next time.